When I was 7, I wanted a Furby because it felt like it cared about me. It didn't. It was a loop of pre-recorded sounds and a spinning gear. But now, we've got models that can learn your speech patterns, your habits, and your deepest preferences. That's why I'm replacing the brain of a 1998 Furby. Same body, same plastic face, but this time it's going to know you. Maybe a little too well. If you were around in 1998, you know the story. Toys R Us, endless lines, Christmas shortages. Furby was the peak of that hype. It got hungry, it got tired, it tapped into this caretaking loop, but with a physical body. The problem is, as an adult, you know just how thin that veil was. I went into this expecting something familiar. I assumed it was going to be a few common servos with a microcontroller. But when I opened it up, the design philosophy was totally different. There are no servos, it's a single motor driving a set of cams. The mechanical parts act as a state machine. The gears dictate the movement patterns. The PCB reflects that same approach. It relies heavily on electrical engineering to minimize the load on the microcontroller. My main goal was always to upgrade the intelligence, but finding out it was built this way meant I actually have to learn how it works. I have to interface with this mechanical system, which completely changes the scope of this project. I went into this expecting to gut it and replace the insides, but I didn't expect the teardown to be quite so brutal, starting with, it's held together by a zip tie, and the pelt is literally sewn into the ears and the top of the head. Zero intention of this ever being opened. But once you get inside, it's fascinating. The main PCB is this incredibly thin piece of plastic, almost hand cut at the edges. You can see the garage light right through it. And the layout? The main board is through-hole, but the MCU and speech controllers are these glob-top secondary boards mounted vertically, held on purely by direct solder joints. Originally I had plans to drop in a Pixel 6 Pro main board and run a local 3B model, but the moment I saw the cam system, I realized my space was way more constrained than I thought. We're dealing with a single bidirectional motor driving the whole setup. It's controlled by 3 parts, a switch sensor that closes once per rotation, an IR receiver capturing pulses from gear slits, and the motor itself handling homing. The sensor inputs are just as unique. The original tilt sensor is a ball bearing inside a plastic housing that makes physical connections to pads as you tilt it. I've replaced that with an IMU on the new board. The speaker is hidden in the belly button, connected via a 4-pin wire. There's a tongue button and a forehead IR sensor, but those are lower priority. Due to the space constraints, the vision for the brain has to change. Instead of the big Pixel 6 Pro board, we're going to be going with the Arduino RP2040 Nano Connect. It's got an RP2040 dual-core MCU, along with onboard Wi-Fi, a microphone, and a 6-axis IMU. The built-in mic is poorly placed for the final design, so it's just for testing. The real plan is to turn this into a web-connected device. The RP2040 handles the local mechanics, but the actual intelligence lives elsewhere on the network. The hardest part isn't the code, it's the interface. I have to talk to this original mechanical system, drive the motor, read the IR slits, and trigger the speaker at the right moments. Bridging that 1998 design with a 2026 microcontroller is exactly where the fun begins. Because the original PCB was so unique, I had to design and 3D print a custom mounting platform. It matches the original footprint exactly, giving me a clean workspace to mount our new components. Right now, the nervous system is coming together. I've got the RP2040 connected and established a Wi-Fi login sequence with a remote status page. This status page isn't actually wired up yet, but it is laid out. While the hardware is being stubborn, the brain is already moving. I've successfully mapped out the software pipeline, speech to text, the LLM, and text to speech. Hello. Right now it's running locally on my machine, taking about 20 seconds for a round trip, but this confirms the logic is sound. The next step is to make this faster and have the RP2040 actually talk to it over the network.
Hello, I'm Test Furby. How can I help you today?
The infrastructure is there. The brain is thinking. Now we just have to make the body move. Hey there. If you made it to the end of this video, I cannot thank you enough for watching. I really do enjoy these projects, and I think that sharing them with the world is another enjoyment that I'm learning how to do. So I really appreciate you watching. I appreciate your time. I do appreciate it. If this is an interesting project to you, the best way to give me that feedback is actually to like. And if you want to see the continuation of these build videos, please subscribe. You'll get, if you hit the bell icon, I guess you'll get notifications when I upload new videos. Some housekeeping items that I want to get out of the way. These videos are going to come at a slower pace now, probably somewhere around once a month. I'm starting grad school, and I'm also working with my brother to get some of his videos going as well. So it's going to be a longer period between videos, but I really want to get Furby working. If you subscribe and you watch the videos, along the way I'm going to be publishing my code, the 3D files, the BOM or bill of materials, so that if you wanted to do this conversion and work on it alongside me and contribute or work together, that would be amazing if everyone wanted to work on it. Also, I will probably eventually create a space for us all to go talk, maybe on Discord or something like that. If any of this sounds interesting, please leave a comment down below. If you have feedback for the video, how it was shot, do you want more technicals? Do you want longer exposure? I scripted this with the help of an LLM, and I can feel in each of the beats that it feels like almost an entire episode inside of my entire video. And I don't know if I like that so much. I'm gonna have to work through that. Obviously there's YouTube tutorials everywhere about how to make YouTube videos, but still trying to work out my process. So again, super grateful that you made it to the end here. Thank you very much. I hope to see you in the next one. Thanks.